We'd like to welcome you to the webinar this afternoon. We appreciate all of you who are able to join. As you can see there on the title slide, our topic today is going to be foreign material contamination and why inline reinspection isn't enough. So joining me here on the call today is Kai Luker. Let me tell you a little bit about my background, and then I'll let Kai introduce himself. I'm the Chief Commercial Officer with FlexXray. I've been here a little bit over 4 years, but been in the world of food safety for 30 plus years. We'll leave it at that. We won't give an exact number on that, but 30 plus years I've been around this world. And so we just appreciate the opportunity to work with you guys. Kai, you gonna do a quick introduction?
Absolutely. Kai Luker, Chief Product Officer here at FlexXray. Been with FlexXray for almost 10 years, and in the food industry, previous 14 years to that, in dairy and in beverage. And excited to bring a little bit of conversation about our technology and how we can support you.
Great. All right. So let's, what we'd like to start with here is some background data that really came from a benchmark survey that we did back in 2025. And while I'm talking about or mentioning a benchmark survey, I'll go ahead and let you guys know, everybody on here, that we'll be doing another one of these probably sometime in June. If not in June, it'll be early July. And because you're here, you all have the opportunity to participate in the benchmark survey. So we really appreciate if you guys would take advantage of that when that opportunity comes about. But when we talk about foreign materials, basically, what we know is that foreign material is really, it's a challenge in the industry that is not talked about at the same level as some of the other challenges that result in recalls. We know, you guys know that most of your recalls tend to be driven by either microbiological concerns or allergens. Those tend to be number 1 and 2, depending on the year. They bounce back and forth, and usually foreign material comes in number 3 in terms of that. And but what we do know is that in 2025 alone, there were 80 plus recalls that were directly related to foreign material contamination. And obviously there's been quite a few, there's been several already in 2026. But we also know that 73% of producers have some type of foreign material incidents at least quarterly. Now, that doesn't mean that there's a recall. It doesn't mean that anybody's aware of it except for the facility where it's going on. But on a quarterly basis, 73% of the manufacturers that responded have some type of a challenge with foreign materials. And obviously, the foreign materials challenges come in many forms in terms of the process. You come in from a raw material standpoint, then in the actual process, and then the manufacturing where we're getting the product out into commerce. So keep that in the back of your mind as we move forward, because these numbers are pretty substantial. Next slide. So let's think about it a little bit. We're moving from in this case, we've got a situation where the metal detector is starting to trip. There's something going on in the process, and what in this situation, what might have been occurring or was occurring, is that a grinder blade started to shred off. They were starting to break apart. And all you guys that do grinding, all you guys that use metal blades for grinding purposes, probably at some point in time in your career, you've had this situation occur that you've got to deal with. And in this situation, the customer ended up with about 100,000 pounds of product that was put on hold. And so once that happens, the metal detector did its job. Now you've got some type of a challenge, but you've got 100,000 pounds of product. The question becomes is, how do you manage the challenge? And really, what are some of the options, or what are the options that you have for remediating the situation? So next slide, we're going to talk a little bit about what those are. This slide is positioned as a question because we initially thought we'd try to do a survey here online, but we're not going to do that. So you just keep in mind that as if you're answering this question. But if this were to occur to you, you got 100,000 pounds of product on hold with some type of metal that is in there. It's been triggered by your metal detector. So what are the most common actions that you would take, or the most common action that you would take in this situation? What we know in the industry is that typically folks will either look to use current inline equipment to re-inspect the product, which is really what the majority of this conversation is going to be about today, and where those challenges come in. Disposing of all the product in the landfill, which is where none of us really want to go, because the goal is to keep as much product as possible in commerce, or working with a third party, like FlexXray, to re-inspect the product. There is another option there when we talk about other, and one of those is might be around downgrading the product, but you'll see some data here in a few minutes while we didn't list it as an option, because it doesn't seem to be something that's recurring on a frequent basis. So keep these in mind as we move forward. So when we look at what's going on, and again, this is information that came straight from the benchmark survey that we did in 2025. About a third of the respondents that responded to this indicated that their first line of defense, if they have a challenge, is to try to re-inspect the product utilizing inline equipment, i.e. the equipment that you've got in line that has already been used to identify the challenge one time, and keep that point in mind as well as we move forward. And it could be that that you're shutting down the line to try to reuse the inline equipment, or maybe in some cases that we're just rerunning the product through the line without totally shutting the line down. Different ways that you manage your business and how you manage it. And then obviously you can see out there that landfilling is still pretty significant in the marketplace. There's a pretty significant number of folks in this survey that noted landfilling product is not uncommon, which is unfortunate when we think about the cost of manufacturing, the cost of the product itself, how landfilling product impacts your sustainability goals, just all of the things that go along with it, especially when we have options in many cases that we can address these kind of concerns to keep product out of the landfill. And frankly, that's why FlexXray exists. That's what our role is to work with you guys to keep product out of the landfill. So keep that in mind as we move forward, and keep in mind the fact that utilizing the same equipment that's been used already to inspect product, to re-inspect product, presents its own certain types of challenges. Okay, I'm going to turn it over to you now and let you talk a little bit about this moving forward.
Yeah, absolutely. Every time I see this slide, I have a little PTSD from my days as a supervisor trying to run a rework or re-inspection crew, whenever something would go down, or on the weekends, or whenever we needed to, as it relates to that. And so, this is just a representation of the process that we're often taking, whenever we do have an event in a food manufacturing plant. We're bracketing that product to ensure that we've got everything we need to on hold. We're allocating resources as it relates to that, and committing to a downtime event because we need to reuse that same metal detector or X-ray to conduct that internal re-inspection of that. We're making a lot of assumptions as we do so, because as Kurt mentioned before, we're re-inspecting that product with the same equipment and methodology that we did the first time to ensure that we didn't miss anything. And we just end up in this cycle where we repeat this process again until we have the next or a new FM event. And so we're constantly in this loop mindset as it relates to rework or reinspection. And it costs us a lot of time, energy, and effort just to be in this mode. And the thing is, we want to try to be in the mode of producing food. That's what we're geared towards. It's what we've spent millions of dollars on equipment and lines and extensions to be able to do. And so every time that we have to stop that process to do rework or reinspection, we're breaking away from our core competency. And so it doesn't have to feel like this, though. So our inline systems should be flagging issues. They don't help us pinpoint them. It's not like a check weigher, an internal X-ray or metal detector. It's just letting us know that we have a problem. And then anytime that we begin re-inspecting with the same equipment, we're really not uncovering the full issue. And so we're essentially rebuilding a data set that is the same as the previous data set that we had whenever we produced the product the first time. And I'll reference FSIS 7310.5 for a moment here, Kurt, because one of the key words that it states in there is that you have to do that reinspection with the most sensitive equipment possible. And if we're just repeating that process with the same equipment, we're not necessarily gaining the additional information that we need. We'll keep going there. And so because of that, we essentially have the same blind spots that we've always had. If we do try to change the sensitivity without really understanding what's going on with our internal X-ray system, we can trigger a lot of false positives, ensuring that we actually are targeting the thing that we're looking for at smaller sizes to build a better data set for hold and release. It's difficult to do at inline speeds with an automated piece of equipment unless you have the internal resources to be able to make those changes the right way. And oftentimes, especially with the advent of technology improvements, we don't. The same type of folks that we had working on an inline metal detector previously that could have improved sensitivity levels, we're not able to do the same thing with an X-ray when we're doing a reinspection. And so we're not technically getting to the root cause whenever we're conducting those processes. And so the big difference here as we do internal rework, it's just not our core competency first and foremost. We're in the business of making food whenever we're a food manufacturer. For FlexXray, our core competency is that inspection overall. From a technology standpoint, and it's not necessarily the technology in itself, it's how we're leveraging that technology. We're not able to slow conveyors down, process the image a different way, make a more robust data set eventually in order to leverage the technology to its fullest. At FlexXray, we're using purpose-driven technology. We'll go into that a little bit further later. And obviously the hidden costs of conducting reinspection without being able to target smaller sizes and gaining that better data set is significant. And Kurt will talk about that a little bit further in a moment as well. And then I know that I've reiterated this data set, but essentially when we're making hold and release decisions, we're trying to gain information about what happened in order to make good decisions about when that event started and stopped so that we know exactly what product to dispose of or to handle differently and what part of that product zone to release back into commerce. The data is of absolute importance. So just to speak of the technology difference a little bit, I want to focus mostly on the run speeds at the top of this infographic. And that's where the majority of the differences between FlexXray inspection and inline inspection occur. With inline equipment, you need to run at production speeds. You need to be able to inspect and maintain your production environment at all times. Whenever there's a hold and we need to re-inspect product down to smaller sizes to ensure that we're getting a good complete data set, the only way to do that effectively is to be able to slow down, to slow the entire process down, to pass more photons through the product for better imaging, to stop binning pixels and only look at single pixel data to maintain the most robust image quality we possibly can, all of those things. And so whether that's a two-dimensional or a three-dimensional X-ray process at FlexXray, our goal is to slow down, find the things, target the right things, and gain a better data set overall. I'll pass it back to Kurt for just a few moments to talk a little bit more about some of the hidden aspects here.
Sorry, I was on mute there. So, yeah, one of the things that we've started having in-depth conversations with our customers about, and possibly some of you that are on the call today, is really what is the real cost of internal rework? Because what we've seen in the past is, well, it's a labor cost, and it's only a labor cost, and we can use our labor to do the project. And when you think about the hard cost associated, obviously labor is a significant piece of that, because you've got to have the people, to do these projects, whether you shut down a line and do it where during the week, which is obviously not the ideal thing to do, or usually you're bringing people on the weekend to shut down a line to do this, unless you've got open manufacturing space. But the other, when you think about it from a hard cost standpoint, is, and a lot of times this is not considered, is in many cases, you guys are going to have contractual obligations to meet customer requirements. Customer requirements around fulfilling orders, fulfilling volumes, and in a lot of cases, these customer requirements will have penalties for not fulfilling orders in a timely manner. And when we're looking at things on a day-to-day basis, or really an hour-to-hour basis, trying to figure out, do we do this internally or not? Those are some of the things, or one of the things that may often get missed. In addition to that, the longer it takes to get a project reran, if we're trying to do it internally, and we're going to have to hold it for a while before we have available labor or available machine. In many cases, you've got storage costs that come into play. So just some things to think about when we talk about it in terms of storage costs. For those of you who have done work with FlexXray, this. For those of you who haven't, I think it's an important data point. But if once we get a project scheduled with you guys, and we get a project on site at one of our facilities, we can typically turn a project around, or an entire truckload around, in around 4 hours, if it's a project that we can run in case. Some cases we can do a little bit less than that, and if it's out of case, it may extend on up 6 hours or a little bit more if we have to take it out of the case, just due to the timing it takes to take it out of the case and repack and those kind of things. But to that point, it's like, if you can turn an entire truck around and get it back into commerce, which you're not going to get the entire truck most cases, but we do know that somewhere between 97-98% of what we inspect goes back into commerce. It really can help with meeting those customer requirements and storage cost. The other thing that a lot of times that aren't considered, and it's something that I think has to be considered if we're going to do a true cost analysis here, is what does it mean in terms of line downtime? So could that line be used for other purposes, to actually produce product versus being down to do rework? And so, of course, the lost production that goes along with the line downtime. And then, as I'd mentioned earlier, it's really the downstream impacts. If we're not meeting those customer needs and we're not getting the orders filled, ultimately it can have situations where your customers aren't happy with us, and they start questioning your ability to be able to provide at the level that they need. We certainly want to stay out of the recall costs, but if we're re-inspecting using the same equipment that essentially kicked out product the first time, and we're not doing a deeper dive to find out what the true root cause is, and to potentially slow things down. We call it the 3 S's, where you got the sensitivity, specificity, and the speed that you need to do these things in a manner that's going to enable you to find things that maybe you're not finding in line. You certainly are opening up that potential recall situation. And the last thing any of us need is brand damage as a result of any of those kind of things. So, as these evaluations are being done, keep this in mind. I can tell you that we with FlexXray have built a calculator. Basically, it's an inline rework calculator that takes some of these things into account, that our team would be more than happy to walk through with you. And you may tell us, hey, that doesn't make any kind of sense in our business, and that's okay, because if it doesn't, that's a data point we need, because maybe we're miscalculating something. But we'd love to have those opportunities to have that kind of conversation with you. So, this is just an example that I'd like to present to you guys, and kind of and show you the ROI potentially on some of these projects. And this is one of these, an example of utilizing the calculator for this purposes. And this one's around 2,200 pounds of 18-pound cases of product. What we know, or what we estimated, is there was production downtime. There's a cost point of about $23,000, labor costs of around $2,000, potential penalties of $1,000. If we're having to substitute different product, $1,000 there. Storage costs that you're looking at is a couple of grand. and then other long-term variable costs somewhere around $5,000. And when you look at that, if you're reworking a project internally, you're thinking, okay, or we're looking at it from the standpoint of that's probably going to cost the customer about $33,000 to do that. Well, in this situation with us, we think this would cost around $2,000, and when we did this calculation, it was before the fuel prices spiked. So let's say it's going to cost $4,000. Let's say it's a bit higher, and we know that to do this amount of product, the way this project could have been ran would cost right around $12,000. And so, if you look at it from that standpoint, the cost to do the project with FlexXray would have been about 14 grand. Versus 33 grand for an internal cost. So really it's a net benefit or a net ROI of around $19,000. Now, again, let's say if we take the fuel cost into consideration, it's closer to $17,000. It's still a pretty significant ROI on a project like this, and you get your results a bit quicker. And of course, we're not even talking about what's going on from a salvage improvement standpoint here. So this is kind of the way this calculator works, the kind of things that we'd like to walk through with you when these opportunities come up, because we think it'll help some of you guys, from a quality assurance or food safety standpoint, in terms of communications with your operational leadership, or if you're in operations, help you guys really look at the true cost as what these projects may cost when we're trying to rework them internally. Okay. Next slide. Kyle, you going to take this one, or you want me to continue to go with this one?
I'll unmute myself. There we go. So again here, reinspection is not our core competency. Manufacturing quality product is. So our personnel on site aren't necessarily trained or oriented to do reinspection tasks. Handling that and ensuring that we're handling the product the right way, that we're maintaining good traceability, good temperature monitoring all throughout this process, and that we're effectively using a piece of equipment the right way to improve that data set. The thing is, we don't have the internal resources in order to be able to do that with modern inspection equipment in a food facility anymore. And so we end up focusing on reusing or repurposing a piece of equipment just for detection again and signaling us, and we're not necessarily finalizing a thorough investigation. And as we work through hold and releases, essentially doing effective CAPA, is critical as it relates to maintaining good documentation and justification, especially from an FSIS perspective. I've mentioned the data set multiple times over, and I think this is really where it becomes critical to ensure that we have the right supporting data for hold and release for those CAPA processes. I referenced 7310.5 earlier as well from an FSIS perspective, which really speaks to, the way that we go about dealing with a product hold from a foreign material standpoint. From a FlexXray perspective, you're going to get robust traceability data, individual pallet information, pallet handling at your fingertip to be able to really understand when throughout this product bracket that I placed on hold did the incident occur, where are the spikes at, where does it begin, where does it taper off, so that we can make really good decisions about finalizing the disposition of that product after the inspection has occurred. The goal in all of that is essentially to break that cycle from a rework loop standpoint, to essentially stay in production mode. And as we bracket product, get sample testing to FlexXray, ensure that we know exactly what we're looking for, what we're targeting, and how we can reinspect that product the right way to remediate your event, so that we get the proper feedback so that you can continue production and continue to improve your production overall. Kurt, I'll pitch it back to you.
Yeah. So before I start the wrap up, I'd like to refer back to, and we don't need to move back to the slide, but the example of the inspection report that Kai shared a bit earlier in the ability to manage the data. I'm sure most of you guys on this call have some type of a relationship with a third-party laboratory, if not, an internal laboratory. And you probably realized, or you probably noticed that that inspection report looks an awful lot like a COA that you may get from a third-party laboratory, or maybe that even you're creating internally. And I bring that up because as you start to get this kind of data back and you start to get these reports back, there is some consistency in what the data looks like. And so as your teams and your analysts and your technicians start to look at the data, start to make decisions, it's really not a total apples and oranges situation. It's somewhat of an apples to apples, because you're looking at very similar layouts for the data and very similar points that's in the data. It's just the results are more material versus maybe microbiology or chemistry. And the important part of that is, if you guys are dealing with some of the third-party companies that give you the ability to upload your COAs, or in our case, your IRs and your audit data, the ability to do that and to build these IRs into your programs, I think is going to be a bit simpler than maybe folks realize. So keep that in mind as you start to look at it. The other thing that is somewhat new to our business is we do now have a customer portal. So you're going to have the opportunity to get directly into your account. So you're going to be able to pull up information yourself and download some details and some information. I'm not going to get into too much detail about that, because I will probably misstate everything that we can do. But there is that capability to use the customer portal that's important to keep in mind in terms of managing your own data internally. So as we start to wrap up, I think it's important to recognize that we need to think about what it means to always look at in-house rework as the best solution. I know that it's the initial reaction that we see is, okay, we got this piece of equipment, we can redo it. But is doing rework on the same piece of equipment really what you need to protect your brand and protect your relationships with your customers? I don't really like to use the analogy, but it's somewhat the definition of insanity is doing the same thing over and over. Tends to lead to the same result. And chances are, if we're doing the same thing over and over, we're going to be getting some information that may be giving us a false sense of security of what's really going on in our process. And we've got to be careful about that and stay away from that. As we look at it, the technology, the cost, and all the knowledge associated when you're looking at these processes of doing internal rework versus comparison with an outside third party, i.e. FlexXray, you really need to build all of these into the equation and into the consideration to make sure that you're really capturing the true ROI for what a project may be. And at the end of the day, when you're looking at external inspection, it's really about reducing burdens and providing you guys with a superior data set to really make sound food safety decisions. Because we've got folks on staff like Kai and his team and our technical commercial team that can have conversations with you about what the data means, what our upfront testing information means in terms of making risk-based decisions. And that's what we're here for, is to help you guys out so you're not having to take that burden on all alone. So, okay, next slide. So, let me talk just a little bit about the FlexXray process, because I think this is important. It's not one of those things where you can call us today and say, hey, I got metal in a box of frozen product. I'm going to ship you 2 trucks tomorrow. We wish it were that simple, and it's almost that simple with metal, because we've done a lot of work with metal over a variety of products. But really the way the process works for us is we do upfront testing on your product, and we'll be asking you guys for a couple of cases of product, as well as potential contaminants that you may have. And if you don't, we've got seeds that we can use, and we will actually test that product up front, and using all the technologies that we have available. And we're going to tell you, we can find the contaminant of concern in your product down to X size, whatever X size may be. Of course, our standard seeds are depending on the contaminant are various sizes and get down to quite small. And in most cases, those are the type of seeds that will work for your project, because oftentimes they're going to be smaller than what you need. And that does expedite a project, and it makes it simpler and cleaner for you guys. But if we need to go smaller than that, we can continue to test, and we can get down to the smaller size. And we're going to come back and tell you, we're going to be able to find this contaminant in this product at 99% repeatability at this size. Now, we may also tell you that we're going to be able to find it at 85% repeatability at a little bit smaller size, but we're not going to be able to find it at the same level of repeatability. But we're going to give you that data, and that's when you have the opportunity to make a risk-based decision around food safety. And it's not uncommon for some of our customers to move forward in those situations, because then the sizes are at a point where they're not detectable. They're not going to create a food safety hazard. It's in a product type that's not going to be going to a population that's more at risk. So there's all those things to consider when you make those risk-based decisions. Once we tell you,
just to
go ahead.
To add to that as well, I know this is not necessarily a technology forum here, but we're also going to leverage, whether that's a CT device, the latest advances in photon counting, or even a medical grade imaging device with our flat panel two-dimensional technology. We've got a lot of technology at our disposal to try to find and target small contaminants in a wide range of product types. So the chances are we have something in our arsenal to help find the thing that you're looking for.
Yeah. Except for, we'll go ahead and say it up front, bag liners and glove tips. We wish we could, but right now it's just not something that we can do at a size that's going to be outside of if it's large enough to be visually seen on the surface of the product. So then we get the product in. We have a logistics team that will work with your logistics team to get it scheduled. And a lot of the work that we do are with folks come, or the trucking company or your logistics guys will show up with the load. They'll stay with it. They'll sit there with it, be an in and out type load. So the driver waits. We turn that truck around in 4 to 6 hours, and they get back on the road with it. And as I'd mentioned earlier in the conversation, 98% of what we do goes back into commerce. Said another way, out of every 100,000 pounds we're inspecting, you guys are saving between 97,000 and 98,000 pounds of product, which is huge, in terms of keeping product, into commerce and into the supply chain. Get that back out to you. Then we give you the inspection report that you saw the example of earlier. As part of going through that reporting process, we can do, and we do double negative. Sorry about that. But what we do is we do a contaminant retrieval, where we will essentially tease out the contaminant that we've identified as being in your product. We'll present that on a piece of paper with labels back to you, so that you've got that contaminant in hand and you understand and you see what's out there. That's something we do for all the customers. It's just a standard part of the process. If you decide you don't want that, you have to tell us that up front, because we feel like the importance of getting that back to you is way more important than slowing down the process to go have a back and forth conversation after the fact in terms of getting that done. And then the last slide that I've got here, in terms of any large detail, the company, FlexXray was founded back in 2001, first office at Arlington, Texas. I want to say Kai's been here that long, but he hadn't been here quite that long. He's been here quite a while, longer than I have. And we are the market leader in what we do in third-party form material inspection services. Right now, we've got 26 inspection lines across 6 states. And we recently opened FlexXray France in Europe, and that was back last fall. And that one is doing extremely well, and we'll be continuing to look at other opportunities in Europe. Facilities have the capacity or the capability of running 24/7. When the work is there to support 24/7, and all the facilities are registered with FDA and USDA. And we AA rated in terms of our BRC audit. So we go through the same type of BRC audit as you guys may go through, but it's more closely related to a distribution center audit than it is a manufacturing facility audit. And when you look at where the facilities are there, I'll bring a little bit of clarity to that. Out west, we're right outside of Boise and Nampa, Idaho, and then we're in Vegas. I've mentioned the one there in Arlington, Texas. The one up in the upper Midwest or in the Midwest, that's right outside of Chicago in Aurora. The one down in the Southeast, it's the address is Fort Mill, South Carolina. The reality is it's 1 mile from Charlotte, North Carolina. So it's right there in that corridor up there. And the one in the Northeast has been in Vineland, New Jersey, but that one is being moved. We left it on there for right now because we're not there yet. But effective next week on Monday, we will have moved that facility from Vineland, New Jersey to Allentown, Pennsylvania into our newest facility. So that's where we're at right now. And we do work with, we know 16 of the top 20 North American food and beverage manufacturers at some level, really depending on what the situations are and the challenges are. In 2025 alone, we inspected 135 million plus pounds of product, which is that's just a huge number when you think about that 98% of that on average stayed into commerce and out of landfills. We got here that's 97% salvage. We know it's a little bit, it's between that 97 and 98. So what this delivers for you guys in the marketplace and the ability to keep product out of the landfill is something that, obviously we're proud of at FlexXray. Kai's been here quite a while, and it's something we think, we hope that you guys continue to take advantage of. So, next slide. So that's where we're at. We'll obviously take questions as they come across here. Not seeing anything right now. Here's one. Let's see here. Kai, I'm gonna let you take this one. What are some of the differences between our CT machine and a typical inline X-ray?
Absolutely. So from an X-ray perspective, it's not different. We are still emitting a fan beam X-ray, and we are picking that the information up and creating an image set on a strip of diodes on the other side. Now, we have 24 sets of diodes because we're gathering a significant amount of information, and we're spinning a gantry around the conveyor at 27 RPM on our CT machine. So essentially, we're able to conduct an inspection on the Y, the X, and the Z axis of the product as we reconstruct all of the slices of that from that X-ray at 0.5 millimeter slices. So the most effective thing that CT gains for FlexXray is that we can find softer profile things like aluminum, gasket, O-ring, rubber materials that typically essentially get masked in product layering effects with a two-dimensional X-ray, because we can strip all of those layers back and see just on a single plane of that image, we can find things that are otherwise invisible to the detector on a 2D X-ray. That inspection is also automated as well. So I may not have been clear about some of our technologies. Our CT and photon counting technologies are fully automated from a detection standpoint. We are continuously updating algorithms via AI and machine learning tools. And our medical grade imaging technology, very robust. We can manipulate KV and MA, contrast, field magnification, a lot of settings with that X-ray unit. But that is a manual inspection process because of the diversity of the way that we can use it.
And I think, Kai, another key point is, you had mentioned this earlier in your presentation, when we're running inline X-rays, we're running at the speed of the production line. So typically 100 to 120, 140 feet a minute. Even with our CT machine, which is, it does run faster than our 2D X-ray machine. but the CT machine in our world is still running somewhere between 12, 15, 16 feet a minute. So when you think in terms of how it runs compared to what you guys do in line, it's running much slower, which gives us the opportunity to look at things a whole lot more specifically than it does if we're running at 100, 120 feet a minute. One other question here. How do you recommend working with you guys when we've got a foreign material incident? It's obviously we want to work with you guys outside of just incidents. and Kai and I have been looking at some programs and processes in terms of how we can potentially do some more proactive things with you guys or with the industry to get ahead of and prevent incidents versus just working when there are incidents. And for example, one of the things that we're talking to quite a few folks about right now is how do we start to build foreign materials or foreign material monitoring into supplier monitoring programs. We know that a lot of the industry has very robust supplier monitoring programs for microbiological concerns, for quality concerns, chemical allergens, those kind of things. Not a lot of detailed foreign material supplier monitoring programs, which I think I know will help get ahead of the curve and take care of some foreign material challenges before they get introduced into the manufacturing environment. So that's one thing that I think we can do in terms of being a bit more upfront and robust. I think there's opportunities for customers to look at things from a standpoint of you're really verifying that your inline processes are working the way that they're supposed to be working. You've already gone through the processes of getting inline X-rays and getting inline metal detectors and validating that those work within your system. But right now, a lot of times you don't know that you may have a challenge or you may have an issue until, unfortunately, you have a foreign material problem. And so what are the opportunities of doing somewhat routine pallets of product just to verify that in fact the metal detectors and the inline X-ray machines are doing what they're supposed to do on your behalf. And we can certainly work with you there in terms of how to better bracket those products and those lots to make sure you're not getting into a situation that could lead to a recall. So, any other questions? Feel free to post them. All right, Kai. If not, Kai, you got anything else in terms of a wrap up? Or
no, appreciate the opportunity to talk a little bit more about our services, Kurt.
All right, guys. Much appreciated, and thank you all for attending.